Section 4.1 is on graphing quadratic functions. A quadratic function is in the form of f of x equals ax squared plus bx plus c. Since it has an x squared in it, that makes it a quadratic function. Anything with an x squared is quadratic. So we call ax squared is the quadratic term, and a cannot equal 0, because if a was 0, then there would be no x squared, and this would be a linear function. We call bx the linear term, because if we didn't have an a in there, it would be very similar to y equals mx plus b. And then c is the constant term. It does not have an x. A, b, and c are going to be numbers. The graph of any quadratic function is a parabola. Its y-intercept, where it crosses the y-axis, is whatever the number is in c. And you'll probably remember this from Algebra 1. The equation of the axis of symmetry is x equals negative b over 2a. Every parabola is symmetric, and it has a vertical line that is that line of symmetry. The x-coordinate of the vertex is also negative b over 2a. So that line of symmetry that goes through the center of the parabola, the high point or the low point is going to be the vertex. And that's how you get the x-coordinate of the vertex. And then to find the y-coordinate of the vertex, just plug that x into the function and calculate what f of x is. Remember, f of x is just a fancy name for y. If a is a positive number, then the parabola opens upward, and the y-coordinate of the vertex is a minimum. If a is a negative number, then the parabola opens downward, and the y-coordinate of the vertex is a maximum. The domain of a quadratic function is all real numbers, and its range is either greater than or equal to, or less than or equal to, the y of the vertex. So, if the vertex is a minimum, it's going to look like this. This is if a is positive, the vertex is a minimum, and the range is going to be y is greater than or equal to whatever the y-coordinate of this vertex is. If a is a negative number, your parabola is going to look like this. The vertex is going to be a maximum, and the range is going to be y is less than or equal to whatever the y-coordinate of this point is. So we're going to do two examples together, and we're going to do all 7 of these things for each example. And then in the homework you'll work on tonight, I want you to do these 7 steps also. Excuse me. We need to find the y-intercept. We need to find the equation of the axis of symmetry. We need to find the vertex. And we'll use that vertex to make a table of values, which we'll use our calculator for as well. We're going to graph the function, state its minimum or maximum value, and then state the domain and range. So let's take a look at a couple examples here. My first one is f of x equals x squared minus 5. So it might actually be helpful to identify a, b, and c. A is the coefficient of x squared, so in this case it's 1. B is the coefficient of x, and notice I don't have an x, so b is equal to 0. And c is the constant term on the end, which in this case is negative 5. So the first thing I need to do is find the y-intercept. The y-intercept is whatever c is, and that's going to be negative 5. Next thing I need to do is find the axis of symmetry, the equation of the axis of symmetry. To do that, I'm going to use x equals negative b over 2a. And in this case, since b is 0, it doesn't really matter what a is. 0 on top is a 0. So don't give me just a 0. It's an equation of a line, and the line is x equals 0. Now that is going to be also going to be the x-coordinate of my vertex. So my vertex is going to be 0 something. Now, if you don't want to take the time and plug it in, we can actually go to the calculator, and this will help us with graphing. So let's put this in and see what it looks like. So we have x squared minus 5. Let's take a look at the graph of that. And as I can see, this right here is my vertex, and I already know that the x-coordinate of that point is 0. So I could actually go to the table. We can make the table now as well. And I'm going to do two numbers smaller than 0, and then 0 itself, since that's the x-coordinate of my vertex, and then two numbers larger. So I'm looking at -2 through 2, and when x is 0, y is -5. This is actually one that isn't too difficult to calculate by hand, but we will be using the calculator here. Since a is a positive number, since a is greater than or equal to 0, it's positive, that means that my parabola is going to look like this, and the vertex is going to be a minimum. And the minimum value is the y value at that point, so my minimum value is -5. Now let's go ahead and make a table, and since I already graphed this, I'm just going to pull my table off of my calculator here. So I had -2, and it was -1, -2, -1, -1, -4, 0, -5, 1, -4, and 2, -1. And you should see symmetry here in your y values. In other words, these two on the top and bottom should be the same. The two around the vertex should be the same as well. So let's go ahead and graph that. So -2, -1, -1, -4, 0, -5, and so on, and your parabola will look like that. And then the last thing we need to do is state the domain and range. Remember I said for all of these quadratic functions, the domain is going to be all real numbers. And the range, since my vertex is a minimum and my parabola is going upwards, it's going to be the set of all y, such that y is greater than or equal to whatever the y of my vertex is. So y is greater than or equal to -5. And I believe those are all of the steps that you need to do. Let's take a look at a second example here. Here we have f of x equals -x² plus 4x minus 6. So let's go ahead and identify a, b, and c. A is -1, b is 4, and c is -6. My y-intercept is -6, since that's what c is. I need to find the equation of the axis of symmetry, and for that I'm going to use x equals -b over 2a, or -4 over 2 times -1, -4 over -2, which gives me a 2. So my axis of symmetry is the equation x equals 2. Don't give me just a 2. I want an equation. X equals 2 is the equation of the vertical line that goes through the vertex of this parabola. Next, I need to find the coordinates of my vertex, and I know that x is going to be, or I'm sorry, 2 is going to be the x of my vertex, and I think I will take the easy way out and just go ahead and use my calculator here. So let's put this function in, -x², let me see, go back here, plus 4x minus 6, plus 4x minus 6. And let's take a look at the graph of that. Okay, and I know that the x of my vertex is going to be -2, so let's go to the table, and I'm going to pick two x's that are smaller than 2, so I'll do 0 and 1. I know the x of my vertex is 2, and then I'll do two numbers larger. So there's the first part of my table, but I notice that when x is 2, y is -2, so that's going to be the y of my vertex. And since a is less than 0, that means my parabola, and actually as I saw from the graph, is going to look like this. It's going to be pointing downward, so my vertex is going to be a maximum, so this is going to have a maximum value at -2. Remember, your maximum or minimum value works off of the y-coordinate of the vertex. And let's go ahead and copy that table. And let's take a look at that. So I have 0, -6, 1, -3, 2, -2, 3, -3, and 4, -6. And again, I did see the symmetry in my y values here, which is what I should have. So 0, -6, and that makes sense, remember, because we said that's our y-intercept is -6. And then 1, -3, 2, -2, and just finish that off there. Oops, I think I missed one of the points, but that's okay, you get the idea. That's what my graph looks like. And now the domain is all real numbers. And my range, since my vertex is a maximum, okay, all of my y values are going to be smaller than that. It's going to be y is less than or equal to the y of my vertex, -2. Okay, so that's how to graph a quadratic function, find all of that information, and as you're doing the homework, I want to make sure that you do all 7 of these steps. They are listed on Schoology under the assignment, and I also have complete solutions posted on Schoology for all of the homework problems as well.